Namaste. In the last class we were in the chapter Mensuration and we have come across in finding the surface area of cube and cuboid. Today we are going to learn in finding the surface area of solid called cylinder. We have seen the circular pillar, road roller, which are some of the familiar examples of a cylinder. Right circular cylinder. Now let us discuss some of the important terms and definitions related to cylinder. A right circular cylinder has two plane circular ends. The two plane ends are parallel to one another, which are known as bases of the cylinder. The line segment joining the center of these two bases is called axis of the cylinder. So here we can see the line segment from A to B is said to be the axis of the cylinder. The radius of the cross section is called the radius of the cylinder. The line between the two ends of the plane, that is called as basis, is called the length, or we can call it as height of the cylinder. So axis of cylinder is perpendicular to the circular ends. So for this reason the solid figure is known as right circular cylinder. So now onwards from here, cylinder will always mean a right circular cylinder. Now let us move finding the surface area of the cylinder. So you can observe here, I have taken a strip of paper having the length L units and the breadth B units. This strip of paper I am going to rotate into the form of cylinder. So I get the strip of paper rotating in the form of cylinder. So by overlapping the breadth of the rectangle, I got the solid as cylinder, but this solid is a hollow cylinder. So I got the figure is hollow cylinder whose length is circumference of a circle. Here the length of a rectangle was taken L units. So here the length became the circumference of a cylinder and the breadth, which was taken as a B units, became the height of the cylinder. So here you can see two cylinders. One cylinder we call it as solid cylinder and the another cylinder we call it as hollow cylinder whose interior space is empty. So this is called as hollow cylinder and this is called as solid cylinder. Now let us find their surface area of the cylinder. So here surface area of the cylinder is nothing but CSA of the cylinder. Then what is CSA? CSA is nothing but the absence of the top and the bottom part of the figure. Means hollow cylinder, you can see this part we don't find, means area of circle is not present. Here also the circle formation face is not present, therefore which is called as hollow cylinder surface area. So we can call it as CSA, whose top and bottom of the face is absent. So instead of writing surface area of the cylinder, we can write it as CSA of a cylinder, where CSA is nothing but curved surface area of the cylinder, which is nothing but area of the rectangle. So here the small strip which I have taken to make the cylinder was in the form of rectangle. Then what is area of rectangle? Area of rectangle is nothing but length into breadth. Then the length of the cylinder has become the circumference of a circle. Then what is circumference of a circle? Which is nothing but 2 pi r into the breadth of a cylinder. The breadth of a cylinder has become the height of the cylinder. Therefore it is taken as h. then the full formula is 2 pi RH. Then the CSA of cylinder is 2 pi RH. So CSA of a cylinder is nothing but 2 pi RH. Since we are finding the area of the cylinder, therefore the units for the surface area of the cylinder will be in square units. Now let us find the TSA of cylinder. TSA of cylinder is nothing but whose cylinder is completely covered, like the upper part is also covered and also the bottom part will also be covered, then we call it as TSA of cylinder. So here the upper part of the cylinder is absent. So if I cover this with the same radius of the cylinder, then I'll get TSA of the cylinder. You can see here one face of the cylinder is closed. It has become like the pen stand. Now I am going to cover even this face of the cylinder also. Now can be observed both the faces of the cylinder have been closed. Then this becomes the TSA of the cylinder. CSA is nothing but the curved surface area of the cylinder. TSA is nothing but the presence of both both the faces, that is on the ends of the cylinder. If both are covered, then it becomes the TSA of the cylinder. Means for the CSA of cylinder, we need to add the area of the circles. Where the area of circles are added? To the ends of the cylinder. Both the bases of the cylinder, we are going to add the area of the circle, then becomes the TSA of the cylinder. So here total surface area of a cylinder, that is we call it as TSA, stands for total surface area of a cylinder, equal to CSA of cylinder plus area of top plus area of base. Then CSA of cylinder we have 2 pi RH plus area of top. Area of top is nothing but area of circle. Area of circle pi r square plus area of base pi r square. So here the radius of cylinder and the radius of circle will be the same. So here 2 pi RH plus pi r square plus pi r square, it becomes 2 pi r square. So if I take 2 pi r common, then the left out is r plus h. H comes from here and R from here. So the TSA of cylinder is 2 pi RH plus 2 pi R square, which is nothing but 2 pi R into R plus H. So CSA of cylinder is 2 pi RH and TSA of cylinder is 2 pi R into R plus H. So if they ask what is the TSA of solid cylinder, then the TSA of solid cylinder is CSA of cylinder plus area of top and area of bottom, which is nothing but 2 pi R into R plus H. Now let us solve worksheet based on this related. First question, find the curved surface area, that is CSA, and total surface area of a right circular cylinder. We know the meaning of right circular cylinder, which is nothing but the radius are perpendicular to the axis, or axis is perpendicular to the radius, whose height is 15 centimeter and the radius of the base in the sense radius of the circle is 7 centimeter. So while solving, first let us write the given things, that is height is equal to 15 centimeter and the radius r equal to 7 centimeter. Before finding the CSA and TSA of the cylinder, first you check whether the units are same. Yes, height is in centimeter and also radius is in centimeter. They are in the same units. First let us find CSA of the cylinder. So CSA of cylinder equal to 2 pi RH. Now substitute the value of pi, r and h. 2 pi, until they stated, you can write pi value as 22 by 7. Radius is 7 and the height is 15. 7 get cancels. Then left out is 2 into 22 into 15. Then 22 2s are 44 into 15. Now find the product of 44 and 15. 5 4s 20, 22, 4 1s 4, 4 1s 4, 0 6 6, that is 660. And here we are finding the area, so it becomes square unit, and the radius and height are given in centimeter, so it becomes centimeter square. This is about CSA. Now we'll find the TSA of the cylinder. So TSA of cylinder equal to 2 pi r into r plus h. Then 2 into 22 by 7 into the radius is 7. 7 plus and the height is 15. This 7 get cancels. 22 2s 44 into 7 plus 15 is 22. Then 44 into 22. Then 4 2s 8, 4 2s 8, 4 2s 8, 4 2s 8, 8, 16 and 9. So the answer is 968. And here TSA is nothing but again a area. So the unit becomes square units. So thus CSA of cylinder is 660 centimeter square and the TSA of cylinder is 968 centimeter square. Now let us solve second question. The diameter of the base of a right circular cylinder is 4.2 decimeter and its height is 1 decimeter. Find the area of the curved surface. He is asking us to find the curved surface in centimeter square. The unit should be in centimeter square. First you write down the given things. So height of cylinder is 1 decimeter and radius of cylinder, not radius, I think diameter is given. Okay, diameter is equal to 4.2 decimeter. Both the units are in decimeter. So we know that 10 centimeter equal to 1 decimeter or 1 decimeter equal to 10 centimeter. So 10 times of centimeter is nothing but 1 decimeter. So here we are going to convert from big to small. When we go for big to small, we need to multiply the units. So 1 into 10 equal to 10 centimeter. Then 4.2 into 10 is nothing but 42 centimeter. Now both the dimensions have been converted into centimeter. Now we can use this in finding the curved surface area. But here the diameter is given, we need to convert into radius, that is r equal to 42 divided by 2 equal to 2 2s 2 1s, that is 21 centimeter. Now you can find the CSA of cylinder. So CSA of cylinder equal to 2 pi RH. Substitute the values. 2 into 22 by 7 into radius is 21 and the height is 10 centimeter. So 7 1s are 7 3s are, then 22 2s 44 into 3 10s 30, then 4 3s are 12 13, that is 1320 and the unit is centimeter square. Thus he asked us to find the surface area of the cylinder in centimeter square and here we have done it. Please write down the conclusion, that is the CSA of cylinder is 1320 centimeter square. Now we'll move to the third question. The curved surface area of a cylinder is 1320 centimeter square and its base has a radius 10.5 centimeter. Find the height of the cylinder. So here CSA of cylinder is given. CSA of cylinder is 1320 centimeter square and the base radius is given, that is r, which equal to 10.5 centimeter and asking us to find the height of cylinder. Keep remember, check whether the area unit and the radius unit is one and the same? Yes, both are in centimeters. Given information is about surface area of cylinder. So that is CSA of cylinder. We need to use the CSA of cylinder to find the height of the cylinder. So CSA of cylinder equal to 2 pi RH. Then area is given, that is 1320 equal to 2 into 22 by 7. Radius is 10.5 into H. Then 7 ones are 7 ones are 7. 0.3 remains, 7 5s are 35. Then H equal to 1320. All these 2, 22 and 1.5 are under multiplication with respect to H. Therefore, they'll come to division, 2 into 22 into 1.5. Then H equal to 1320 into 10, because after point we have one digit. So I'll make it 10, multiply by 10 in the numerator, and this 2 into 22 into 15, I'll keep it as it is. Now you can go for cancellation. 2 ones are 2 5s are 10, right? 5 ones are 5 3s are 15. 3 ones are 3 4s are 12. 1 remains, 3 4s are 12, 0. Then 22 ones are 22. 22 2s are 44, and this 0 as it is, which implies height is equal to 20 and the unit is centimeter. Therefore, the height remains in centimeter. Thus, height of cylinder equal to 20 centimeter. Now let us move to fourth question. The circumference of a base of a cylinder is circumference of the base of a cylinder, which will be in the form of circle shape, is 176 centimeter and its height is 65 centimeter. Find its lateral surface area. Lateral surface area is nothing but CSA of a cylinder. So circumference of a base of a cylinder equal to 176 centimeter. That is, circumference of circle is 2 pi r, whose value equal to 176 centimeter, and the height is given equal to 65 centimeter. Here circumference of cylinder is in centimeter and also height is in centimeter. No need of conversion of any unit. And here is asking to find the lateral surface area. CSA of cylinder. We know that CSA of cylinder equal to 2 pi RH. We have the 2 pi r value. The 2 pi r value is 176 into 65. So what's the resulting answer? 176 into 65. 6 5s are 30. 7 5s 35, 38. 5 1s 5, 3 8 into 6 5s 6 6, 36. 6 7s 42 plus 3, 45. 6 1 6 plus 4, 10. Then 0. 8 plus 6 is 14. 8, 9, 10, 14, 1 and 1. So we got 1, 1, double 1, double 4, 0, and unit is centimeter square. So thus the CSA of cylinder is 11,440 centimeter square. Now let us move to fifth question. The radii of two cylinders are in the ratio 2:3 and their heights are in the ratio 5:3. Calculate the ratio of their curved surface areas. So here two cylinders are given and the radius are given in the ratio. So let me take x, that is 2x as radius of cylinder 1 and 3x as radius of cylinder 2. So with respect to the same cylinder, height is given. Since two ratios are given, children, so one variable stick it as x to remove the radius of two cylinders, and to remove the height separately you take the common ratio be y. So 5y 5y as height of cylinder 1 and 3y as height of cylinder 2. So after doing that, he is asking to find the ratio of their curved surface area. So let me take directly the ratio here. So ratio equal to CSA of cylinder 1 by CSA of cylinder 2. Then CSA formula is 2 pi RH by 2 pi RH. So 2 same, pi same. Please don't cancel with the R and R because the radius of two cylinders are different. So one cylinder radius is 2x into height of cylinder 1 is 5y divided by radius of cylinder 2 is 3x into the height of cylinder 2 is 3y. So same variable get cancels here. Then product of these two, 5 into 2 is 10 and 3 into 3 is 9. Therefore, the ratio of the cylinder is 10:9. This is the final answer, children. So now let us move to the sixth question. The outer diameter of a gas cylinder is 20 centimeter. Find the cost of the painting of its outer curved surface area. Outer curved surface area in the sense only the CSA painting is asking at rupees 4 per centimeter square or at rupees 4 per square centimeter if the height of the cylinder is 70 centimeter. So let us write the dimensions. What is given? Diameter is given. D equal to 20 centimeter. Convert the radius. Radius equal to diameter by 2, which is nothing but 10 centimeter. And the height is given. The height of cylinder is 70 centimeter. And the cost is given. Cost 1 centimeter square, because he gave per square centimeter is nothing but 1 centimeter square equal to rupees 4. And the painting is done only the outer curved surface. Outer curved surface is nothing but CSA. So CSA of cylinder equal to 2 pi RH. Substitute the value 2 into 22 by 7 and the radius is 10 and the height is 70. So 7 ones are 7 tens are. Then 2 into 22 into 100. Then 22 twos are 44 and this 00 as it is centimeter square. So here we got CSA of cylinder is 4400 centimeter square, but he is asking the cost. So 1 centimeter square equal to rupees 4. Then for 4400 centimeter square equal to how much? Therefore, total cost of painting equal to 4400 into 4, then 4416, 16 plus 1 17, 00 rupees. So this is the total cost, that is 17,600. Seventh question. The cylindrical vessel open at the top has a radius 10 centimeter and height 14 centimeter. Find the total surface area of the vessel. Don't take total surface area of the vessel equal to 2 pi r into r plus h. Here the condition is given open at the top means the top circular region is not present in the given cylindrical vessel. So therefore I'll go with the CSA of cylinder, that is curved surface area, and I'll add the base area of the cylinder. Then I'll get a cylindrical vessel with the open at the top. Or you go with the TSA of cylinder, that is closed TSA of cylinder, and do minus area of circle because he told the open at the top. Any ways you do, you will get the solution, children. So first let me write the given information. Radius is given 10 centimeter and the height is given 14 centimeter. Both the units are same, children, here, and pi value asked us to take 3.14. So I'll tell surface area of cylindrical vessel equal to, I'll go with CSA of cylinder and I'll add the base, that is area of the base. Area of the top and base are in the form of circles, so you can add pi r square here. CSA of cylinder is 2 pi RH plus area of circle is pi r square. First you take out the common. Pi and r is common here and left out is 2h plus r. Now substitute the values of h and r. So 3.14 into 10 into 2, h value is 14 plus 10. So 3.14 into 10 becomes 31.4 into 14 to is 28 plus 10. Then 3.14 into 38 multiply, so which equal to 11932, but after decimal point we have 2 digits here, so 119.32 and the unit is in centimeters, so centimeter square. Thus area of vessel equal to 119.32 centimeter square. Now we'll move to 8th question. Now we will solve 8th question. The length of a roller is 40 centimeter and its diameter is 21 centimeter. It takes 300 complete revolutions to move once over to level the floor of a room. Find the area of the room in meters square. So here he wants us to find the area of the room in meter square, but the dimensions are given in centimeter. Roller generally we find in the form of cylinder. Therefore diameter of roller equal to 21 centimeter and the radius, we know that radius is nothing but half of diameter, that is 21 by 2 centimeter, and we know that 1 meter equal to 100 centimeter. 100 centimeter is nothing but 1 meter, then 1 centimeter equal to 1 by 100 meter. So here the radius which is in centimeter is converted into meters, that is 21 divided by 2 into 100 meters, that is 21 by 200 meters, and height, that is length of the roller is 40 centimeter. So 40 by 100, 0 0 get cancels, 2 2s are 4, 2 5s are 10, so we get 2 by 5 meters. As I told you, the roller will be in the form of cylinder. So to level the floor, so here we need to find the CSA of the roller, right? So CSA of the cylinder is nothing but 2 pi RH. So first you find for one revolution how much area it covers, then you multiply the resulting area into 300, then we'll get the total area of the floor. So CSA of cylinder is equal to 2 pi RH, then 2 into 22 by 7, and the radius we have 21 by 200 into height 2 by 5. Then 7 ones are 7 3s are 21, 2 ones are 200s are, then it doesn't get cancels with any table, so you multiply, which equal to 22 into 3 into 2 divided by 100 into 5. This is about meter square, but this is of only for one revolution, but the given question is asked for 300 revolutions. Therefore area covered for 300 revolutions equal to 22 into 3 into 2 divided by 100 into 5 into 300. Then 00 double 0 get cancels. Further cancellation is not possible, so we will multiply 22 into 2 is 44 into 3, and here 3 divided by 5, then which equal to 44 into 3 3 is 9 divided by 5, then 9 4s 36, 36 plus 3 is 39 divided by 5, then 5 7s are 35, 4 remains, 5 9s are 45, 0.1 remains, then 0.0, then 5 2s are 10 meter square. Since he is asking in meter square the area, so the answer kept in meter square, children. So the total area of the base of the room is 79.2 meter square. So the end conclusion must be written, children. So the area of the room is 79.2 meter square. Now we will move to solving 9th question. A closed metallic cylinder has its base diameter 56 centimeter and it is 2.25 meter high. Find the cost of the metal used to make it if it cost rupees 80 per square meter. So first we will write all the given things. So the diameter is given 56 centimeter. Then convert into radius. We know that radius is half of the diameter. So 56 divided by 2 equal to 2 2's 4. 1 remains, 2 8 16, that is 28 centimeter. And the height is nothing but height, which equal to 2.25 meters. Here the dimension is in centimeter, that is radius in centimeter, and the height is in meter. We know that 1 meter is nothing but 100 centimeter. So 2.25 into 100 centimeter. Then the height remains 225 centimeter, because these two zeros makes this point to shift towards the right side after 2 digits. Now the radius is in centimeter and the height is also in centimeter. But here it is given in meters. So better I'll keep this in meters only, children. So I'll consider height as 2.25 meters only. Before I could not see. So now I have seen. So here the area, cost is given in meters. So convert better into meters only. Then 28 divided by 100, which equal to 0.28 meters. Take radius as 0.28 meters and the height as 2.25 meters. I am considering this because the cost is given in meters, square meters. And here closed metallic cylinder is required. Cleared? Therefore, we have to take TSA of cylinder. TSA of cylinder equal to 2 pi r into r plus h. Substitute the values. 2 into 22 by 7 into radius 0.28 into 0.28 plus height in meters, that is 2.25. So 7 ones are 7, 7 4s are 28, but after point we have 2 digits, therefore 1, 2 point, that is 0.04. 22 2s are 44 into 0.04 into addition of these two, 8 plus 5 is 13, then 2 plus 2, 4 plus 1, 5, point 2 plus 0 is 2. Now multiply all this. So first let me multiply 44 into 0.04, 0.04, 4 4s are 16, 4 4s are 16 plus 1, 17, but after point we have 2 digits, so 1.76 into 2.53. Now the multiplication of these two is 4.4528 meter square. The answer did not end till here because he is asking the cost. So cost for 1 meter square, or it can be said as square meter, is rupees 80 then cost for 4.4528 meters square equal to question mark. Then total cost equal to 4.4528 into 80 rupees. So we get 356.224 in rupees. That's all, children. So the total cost of metal required, which is used to make the TSA of a cylinder, is 356.224 rupees. So this is how we need to solve, children. Now let us move solving 10th question. A rectangular piece of paper is 22 centimeter in length and 10 centimeter in width. It is rolled into a cylinder along its length. Find the surface area of this cylinder. As I already said you that the CSA of cylinder is nothing but area of rectangle. You see, this is the paper which is in the rectangular in shape. If I roll along its length, then the length of a cylinder becomes the length of a rectangle becomes the circumference of a circle in the denominator. In the bottom of the paper. Therefore, here he is asking us to find the surface area of the cylinder. So, the surface area of the cylinder is nothing but the area of the rectangle. Direct you substitute and find its answers, children. So, surface area of the cylinder is nothing but area of the rectangle. Then which equal to L into B. The length of the piece of paper is given 22 centimeter into breadth of the paper is given 10 centimeter. Both the units are same, centimeter. Therefore 22 into 10 is nothing but 220 centimeter square. That's all, children. So write the conclusion. Thus the surface area of the cylinder is 220 centimeters square. Now let us move to 11th question. A cylindrical well is 21 meter deep. Its outer and inner diameters are 21 meter and 14 meter respectively. Find the cost of renovating the inner curved surface area and outer curved surface area at the rate of rupees 25 per meter square. So first let us write the given things. Solution. So deep stands for height. So height of cylinder equal to 21 meter and inner diameter D1 is nothing but 21 meter. Then find its radius R1 21 by 2 meter. Then outer diameter D2. Outer and inner. Okay, this is outer diameter D2 R2, inner diameter D1 which is 14 and radius R1 that is 14 by 2 which equal to 7 meters. Here in the question he gave respectively, means outer diameter is 21, inner diameter is nothing but 14, and is asking us to find the total cost of renovating the inner curved surface area and outer curved surface area. First we'll find the area, then we'll go for cost. So first CSA of inner equal to 2 pi RH, then 2 into 22 by 7 into radius. Inner we are finding, right? Inner is nothing but, this is inner ones and this is outer ones. So inner we have the radius as 7 into height is nothing but common whether it is inner or outer. Then 7 get cancels. 22 2s are 44 into 21. Now multiply and find what is 44 into 21. So the 44 into 21 is 924 meters square. And here the cost is given in the meter square only, so we keep it in the meters only. Next, CSA of outer cylinder or outer cylindrical well, 2 pi RH, which is nothing but 2 into 22 by 7 into outer is nothing but outer diameter, that is 21 by 2 into height remains same, that is 21. Then 7 ones are 7 3s are 21, 2 ones are 2 ones are, which equal to 22 into 3 ones are 3 and 3 2s are 6. So if you multiply 63 into 22, the product is 1386. 1386 meter square. So after finding the inner and outer curved surface area of cylindrical well, now you write it total area. Total area equal to 1386 plus 924. So 924. If I add up, the resulting is 2310 meter square. Then cost for 1 meter square. The cost for 1 meter square is 25 rupees. Then cost for 2310 meter square equal to how much? Therefore, total cost for renovating is nothing but, we will get, if we multiply these two, that is 2310 into 25. Then the product of these two is 57,750 rupees. 57,750 rupees. This is the total cost. So this is how we need to solve for TSA and CSA of cylinder, that is cylindrical figures. So here I'll solve example 11. Example 9 and 10, solve it by yourself, children. In a building, 15 cylindrical pillars are to be painted. The diameter and height of each pillar is 48 centimeter and 7 meters respectively. Find the cost of painting if the rate is rupees 2 per square meter, means the unit should be in square meters. So here there are number of 15 cylindrical pillars and the diameter is given 48 centimeter, which is nothing but radius will get 24 centimeter. Since the cost is given per meter square is rupees 2, so I'll convert the radius into the form of meters. So we'll get divide by 100, we'll get 0.24 meters. And the height of the cylinder is given 7 meters. Already the unit is in meters, no need of conversion. So here painting of pillars is done only for the curved surface area. Therefore I'll find curved surface area of one pillar is nothing but 2 pi RH. Substitute the values of radius and the height. We'll get the CSA as 10.56 meter square. Since it is given 15 cylindrical pillars, therefore I'll multiply the obtained CSA of one pillar into 15. So we get 15 CSA of pillars, that is 158.4 meter square. And he is asking cost of painting to find. Therefore total cost equal to 158.5 into, for 1 meter square the cost is 2 rupees. Therefore multiply it with 2, we'll get rupees 316.80. So this is all about today's class, children. Thank you. Have a nice day. Thank you, children.